All right. So, good evening to everybody. We're going to be in page 35 of our workbook. So, if you do not have your workbook out, this is a great time to get your workbook out. We are going to be in our activity sheet 9. So, I'm going to go to block 9 activity sheet, and I'm going to get this pulled up for us. And so, basically, today, what we're going to be doing is we're applying proportional reasoning to scaling mixtures. And we're going to be enlarging and reducing objects using ratio tables and equations. So the first thing we're going to do is I'm going to start us off with an opening question. And that opening question is kind of going to relate back to work that we've already done and just common sense. All right. So if we're mixing juice and that juice takes 1 cup of concentrate and 1 cup of water, and then I get another juice and I get 1 cup of concentrate and I only put half a cup of water. How is that going to affect the taste of the juice? How would they be different?
If there's more cups of water, then the juice would be more watered down.
That's right. So that first one that has a 1-to-1 ratio, it's going to taste exactly how it's supposed to. All right. But that second one that only has a half cup of water, would it be stronger or more watered down?
Watered down.
All right. Remember that second one, I'll write it up here for us. So the first mixture is a 1-to-1 ratio. So it's 1 part juice to 1 part water. And the other one is 1 part juice to a half cup of water. So out of these two, which one would taste more like juice?
The 1-to-1.
All right, I got one person that says the 1-to-1. What would the 1-to-1/2 taste like?
Would it be stronger?
Yes, it would be stronger. All right, so this one would be stronger, and the 1-to-1 would taste how it's supposed to taste, but the 1-to-1/2 would be a lot stronger because it has what?
More concentrate than water.
Yeah, it has more concentrate than water. Or we could say that it has less water than the other mixture. Good. So what was the ratio of juice to water for each one? What were the ratios?
The first ratio is 1-to-1. Can you talk about the one we just wrote?
Correct.
The first one is 1-to-1, and the second one is 1-to-1/2.
Perfect. All right. So does anybody have a question about how those would taste different? Or does everybody pretty much understand what we're talking about so far? Give me a thumbs up if you understand. All right. Looking pretty good. So I'm going to take this off of here and we're going to get started on our classwork. All right. So looking at our classwork today, we're going to be looking at fruit drinks and how to make those fruit drinks for different amounts of people. So if you would go ahead, Alora, and read this for us, please.
Question number 1.
I want you to actually read about from reinforced fruit drinks all the way through question number 1.
You are a taste tester for a fruit drink company. The company is designing new drinks using orange concentrate. The concentrate needs to be mixed with water. The manager of research and development is trying 2 different recipes. It is your job to taste them. Recipe 1, 3 cups of concentrate for every 7 cups of water. Recipe 2, 2 cups of concentrate for every 5 cups of water. What if the manager wants to make more than 1 batch of each recipe? Complete the tables to show how much of each ingredient the mixers will need.
All right, good deal. So looking at this first batch, if we're looking at the batches, The batches are kind of like what? We've been talking about it this whole time. Starts with a S. The batches are like
Scale factor?
a scale factor. That's correct. All right. So, and we know that scale factors are used to change an original figure so that it's either enlarged or reduced. And how does those scale factors work? What do we do with them?
Multiply them.
That's right. We multiply them by the original figure or mixture. And in this case, the original one is 3/7, and the original on recipe 2 is 2/5. So I want you to take a minute for each one of these. So that'll be 2 minutes. And I want you to see if you can find all of the mixtures. So I want you to do that now. Okay, let's check our work. So looking at this, on part 1, on recipe 1, who can help us? Nobody's too excited to work. We'll fix that.
Miss Martin,
Yes.
I thought it was 6.
It is 6. Good job. All right. So we're going to put that there. 6. All right. Hagen, what would this one be?
14.
Good. All right. Angel, what would this be?
9.
All right. And what would this side be, Angel?
21.
Good. Kalia, what about the next one?
I got 15 for orange concentrate and 35 for the water.
Perfect job. All right. And let's see. Asia, what about this last one? What'd you get?
I got 30 and 70.
Great job. So tell me this, Asia, while you're still on here. How are y'all getting these answers? What are y'all doing?
You're multiplying by 3.
Correct. Okay. So like in this one, we're doing 3 times 2 and 7 times 2. And in this one, we did 3 times 3 and 7 times 3. And then on this one, what do we do?
Five times 3.
Good. And 7 times 5 also. Then on that next one, what did we do?
10 times 3 and 7 times 10.
Good. Good. All right. So we're going to take this information and we're going to fill out part 2 or recipe 2. So Hamarjane, help us out with this one. What would we get for making 2 batches of recipe 2? What would we do?
I'd say 4
Good.
and 20.
4 and how many?
20.
All right. So let's look at it. For this one, we did 2 times 2 and got 4, right?
Yes.
And what's 5 times 2?
10.
Yeah. So should it be 10 or 20?
10.
There you go. Good job.
Well,
All right. Let's look at the next one. Kyron, what would we get for having 3 batches of recipe 2?
I got 6.
Good. And what would you get for here?
7.
5 times 3?
No. All right. I don't know that one. I didn't get that one.
All right. So we did 2 times 3 and got 6. So we need to do 5 times 3 and get
15.
good.
Get that.
All right. Brooklyn, what can we do to get this one? The number of batches, 5 batches. What can we do?
5 times 2 equals 10, and 5 times 5 equals 25.
Good. All righty. Let's see someone else. Tamarian, what could we do for this one, Tamarian?
Orange considers 40.
All right. So, what would you do to get that answer? We got to do 2 times what?
2 times 10.
That's right. And what is 2 times 10?
20.
That's correct. All right, good job on that one, Tamarian. So, what would we do to find the amount of water? What would we need to do?
For me,
Yeah,
5 times 10.
good job. What's 5 times 10?
50.
Perfect. Anybody have a question? Good. Let's keep moving. Oh man, I thought it was going to keep my numbers, but it didn't keep my numbers. That's all right. I'll keep my numbers down here. Okay. All right, number 2. Read that for us, Brooklyn NN.
The manager wants to make 100 batches of recipe 1. How many cups of orange concentrate does she need to add?
All right, so remember that the original recipe was how much? 3 to what?
7.
Good job, Brooklyn. All right. Now, since it was 3 to 7, they're saying that they want 100 batches of recipe 1. But all they're worried about is how many cups of orange juice they need. So, what would we need to do to determine how many cups of orange concentrate we would need?
Divide.
All right. If we divided, would that be enlarging or would that be reducing? That'd be reducing the amount of batches they need. We're trying to enlarge the amount so that we'd have 100 batches of recipe 1. So what could we do, Kalia?
Multiply 100 times 3.
That's right. And what is 100 times 3?
300.
Good. So since we know that the answer is 300, can you put that in a complete sentence of how many cups of orange concentrate she needs to add?
We would need 300 cups of orange concentrate.
That is correct. Does anybody have a question about number 2? All right, we're going to move to number 3. Remember, this is in page 35 of your workbook. All right, number 3. Read that for us, please, Akira.
Which of the 2 recipes has a stronger orange flavor? Explain mathematically how you know.
All right, so what I want us to focus on in this, remember this was recipe 1 and recipe 2. Is there anywhere where there's the same number of orange concentrate? Remember, this was orange, this was water. This is number 1, and this is number 2.
No.
All right? I disagree. I think there is a spot where they both use the same number of orange concentrates. Does anybody see it?
10.
All right. 10. There's not a 10 up here.
Oh, I was looking at the wrong.
Rachel, what do you think?
I think it's 6.
It is 6. So if we look at it, this ratio is 6 to what?
14.
That's right. And what's the other one?
6 to 15.
All right. So if this is 6 to 14 and this is 6 to 15, and remember this is water and this is the orange juice. So what does that tell us about number 1 compared to number 2?
It has less water, so it's stronger.
That's correct. Good job, Angel. That's correct. So looking at number 3, it said which of the 2 recipes has a stronger orange flavor? Which one has a stronger orange flavor?
Number 1, because it's less water.
Good job. Perfect answer. All right. And we know that because when both recipes have the same number of orange concentrate, recipe number 1 has less water than recipe number 2. Does anybody have a question about that problem? All right, we're going to keep moving. If you would, Braden, would you read number 4, please?
Suppose you had only 1 cup of orange concentrate. How many cups of water would you need to make a drink with the same taste as the recipe 2?
All right, so what was the original ratio of recipe number 2?
2 to 5.
Correct. It was 2 to 5. All right. And so if we set up a proportion, and this is 2 to 5, and remember they want to have 1 cup of orange concentrate, so we need to figure out how many cups of water we would need. So what's taking place for 2 to become 1? What number do we multiply 2 by to become 1?
You divide it by 2.
You divide it by 2 or you multiply it by 1/2. So what is 5 times 1/2, or what is half of 5? What would that be?
2.5.
That's correct. Since this is 2.5, how would we answer our question? What would we say?
You would need 2.5 cups of water to make an equivalent ratio.
All right, so that it would taste the same as recipe number 2? If you only had 1 cup of orange juice?
Yes.
Perfect job, Angel. Great job. All right, does anybody have a question about what Angel just did there on number 4? Good job, Angel. You did a great job explaining that. All right, let's look at the next one. Talia, will you read 5 for us, please?
You only want to make a gallon of recipe 1. How much concentrate and how much water do you need? 1 gallon equals 16 cups. Explain your solution.
All right, so thinking about this, what is the original ratio for recipe 1?
3 to 7.
Good job. 3 cups of orange juice to 7 cups of water. All right, how many cups is that in all? What does this equal in total? This is 3
10.
cups and this is 7 cups. So what did we get, Angel?
It's 10 cups.
10 cups. Good job. So since we know this is a total of 10 cups, what could we do to figure out what we would need for 16 cups? Could we just find one and then find the other? Is that possible?
Yes.
All right, let's try it, Kalia. So let's take the orange juice. We know that there are 3 cups of orange juice for the total amount of cups. So I'm going to put my total amount of cups, and I'm going to set it equal to the total amount of cups we want. We want how many?
16.
16. So I'm going to try my hardest to figure out what this would be. So in order to do that, I need to look and see how much I'm trying to enlarge this by. So in other words, what number times 10 equals 16? How can we find that answer out? What would we need to do?
Divide 10 by 16.
That's correct. All right. I think we need to do 16 divided by 10. All right. So 16 divided by 10, what does that equal?
1.6.
That's correct. So what do I need to do with 1.6 now? Since I know 10 times 1.6 is 16, what should I do up here to figure out what this is?
3 times 1.6.
Perfect. And so what is that answer going to be?
1.8.
4.8 is right. All right, so remember, this is how much orange juice we need. So since we have this information, what do I do to figure out how much water we need now? What could I do?
Do the same thing to the 7.
Sounds good. Let's do that. 7 times 1.6. What does that equal?
8 point. I know.
Try it again.
11.2.
11.2. Good job. And so if you add 11.2 and 4.8, what does it equal?
16.
It equals 16. So it says, how much concentrate and how much water do you need? Somebody put that into their own words. How much water and concentrate do we need? Hagen, how much concentrate and how much water do we need?
You only need 4.8 cups of concentrate and 11.2 cups of water.
All right. And how did we find our answer?
You multiply 3 times 1.6 and you multiply 10 by 1.6.
All right. And the reason we multiplied by 1.6 is because 10 times 1.6 equals 16 cups in all, and that's what they wanted to know. So we took 1.6 and multiplied it by our original measure of orange juice and our original measure of water to determine our new measurements or our new ratio. All right? So we would have the correct amount of concentrate to water for 16 cups. All right, looking at graph 6. Let me erase this off of here. So for graph 6, if you would, Rachel, will you read that for us, please?
1 for each recipe. Use the value from the table you completed in question 1. Label each line with the number of recipes.
All right, so what I want you to do is I want you to graph recipe 1 and recipe 2 on page 35 of your workbook. I'm going to give you about 4 minutes to do this. You're going to use recipe 1 and recipe 2 where we enlarge them to be able to graph this. You only need 2 points from each one, okay? All right, my girls and guys, let's see what we got. All right, so first thing that I need to do is I need to focus on how many cups of concentrate that I need and how many cups of water I need. So if you're looking at our tables that we created, what should we number each one of these to?
X and Y.
Okay, so this is our X, this is our Y. So we have that labeled. But I also want to label this in numbers. So I want to start doing that now. So how high do I need to go up to on my cups of water? Does it really matter? How about we go to 15? So I got 1, 2. I'm going to label this all the way to 15. If you haven't done that, make sure you're doing that now. All right, and then I'm going to do the same thing for my cups of concentrate. I don't like how that looks. 1, 2, 3. All right, so everybody should already have theirs labeled and hopefully graphed by now. So when we look at this, let's take 2 of our ratios from recipe 1. So on number 1, what 2 recipes or what 2 recipe ratios do we want to use? What was the first one? 3 to what?
7.
Good. And what was the other one, Hagen? Wasn't it like 6 to what? 6 to what, guys?
14.
Good. All right, so in order to graph this, what we're going to do, remember that this is the water and this is our what?
Concentrate.
Our concentrate. So we're going to go, let's follow our water. So we had 7 cups of water, which is right here, to 3 cups of concentrate. 1, 2, 3. All right, and then we had, and I know this looks funny because a lot of times when we're doing X and Y's, our X is going to come first. But in this case, our ratios were listed backwards. But we know that water, in this case, is X because X is horizontal and Y is vertical, okay? So when we're looking at this, we're going to do our next one, which is 14. So I'm 14 units to the right, and then I'm going up 6. So that's 1, 2, 3, 4, 5, 6. And then I'm going to do my best to draw a straight line, and I can tell you that it's not going to look good, but I'll do as good as I can with this mouse, okay? All right, so that is number 1, recipe 1. Now we need to do the same thing for recipe number what?
2.
2. All right. So what was the original ratio? It was 2 to what? 2 to 5. All right, so that means we got to go over 5 units. So that's 1, 2, 3, 4, 5. And then I'm going up 2. All right. And then the next one was 4 to what?
10.
Good. So I'm going over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going up 1, 2, 3, 4. All right, and I'm going to do my best to draw this line out for us. Remember, we got our 2 here. We got that here. All right, so you should notice a difference between number 1 or recipe number 1 and recipe number 2. Which one's steeper?
Recipe 1.
Recipe 1 is steeper. Why is recipe 1 steeper? What does it have more of?
Concentrate.
It does. It has more concentrate. So recipe 1 has more concentrate, therefore it's steeper. And recipe 2 has more what?
Water.
It has more water than recipe 1. That's why it's not as steep as number 1. So right there it said to explain the graphs and how they are alike and how they're different. Well, they're both what? What are they both? Everybody should know this. Don't make it hard. They're both what?
They're both juice.
They are both juice. All right. And on this graph, they both make what? They're straight.
Lines.
There you go. Straight lines. Okay. So they're alike and they both make lines and they're both straight. And they're different because number 1 is what compared to number 2?
Steeper.
It's steeper. And the reason we said it's steeper is because it has more what?
Concentrate.
More concentrate. Good. So, still working with that, it says, how does the steepness of the graph relate to the taste of the drink? So, the steeper that the graph is, the taste of the drink is going to get what? Stronger. Good job, Angel. Great answer. Does anybody have a question why it's stronger?
Because more concentrate.
That's right. Great job. The more concentrate we have, the stronger the taste it's going to have. All right? Great job. Y'all are doing perfect. All right, so I'm going to erase this off of here. And then we're going to knock out question number 9. All righty. Let's get Miss Kaylee. Can you read 9 for us, please?
You have been given a recipe for a completely new fruit drink. The recipe has 3 parts. Here's the recipe. Do you want me to read that?
Yes, please.
Okay. Fruit drink recipe: 2 parts pineapple juice, 3 parts cranberry juice, and 5 parts lemon juice. You need to make 1 quart, which is 4 cups cups of juice for the taste test. How much of each ingredient do you need? Explain your solution.
All right. So I want you to think of this recipe as having 10 total parts because there's 2 parts of pineapple juice, 3 parts of cranberry, and 5 parts of lemon. Okay? So since there's 10 parts in total, what we're going to do is we're going to set up a proportion. So we know there's 10 total. And what do they give us first?
Pineapple juice.
Pineapple. And how many parts of pineapple are there? 2. All right, so we're going to set this equal to the total amount that they want us to have. The total they want us to have is what?
4 cups.
And since they want us to have 4 cups in total, we have to determine how much that's going to make, or X cups of pineapple juice that's actually going to make. So when I say X, X just really stands for a question mark, okay? So X is a variable that stands in for an unknown value, okay? So X cups of pineapple. So what could I do to determine this?
Multiply.
All right, so you are correct. I'm looking for what number I can multiply by 10 and get 4. So is that number going to be bigger or less than 1?
Bigger than?
Well, if you think about it, if 10 is a bigger number than 4, right? So that means that I have to multiply 10 by a number that's less than 1 so that it shrinks, so it reduces in size. So I'm looking for a number that I multiply by 10 and get 4. So what could I do to determine this number?
Divide.
Good job. So I'm going to take 4 cups and I'm going to divide it by 10. And we know that 4 divided by 10 is equal to what in decimal form? You say it just like this.
4.
4/10. Good job. So since this is 4/10, I need to take 2 and multiply it by 4/10. So what is 2 times 4/10?
8.
That is 100% correct. Good job. All right. So now we need to find what the cranberry juice is in part. So this is 8/10 cups of pineapple in our original mixture. Okay. So now we need to do the same thing for the cranberry and the lemon juice. So I want you to try to do that now. So how could we set it up? What could we do? How many parts of cranberry are there?
3.
Good. And how many are there in total?
10.
Good. And we want to set it equal to what we want, which is
4 cups.
good. And we've already done this math. We know that 10 times what is 4? What do we get?
0.4.
Correct. So I need to do 3 times what?
4/10.
Times 4/10, and that will give us y. And remember, y is just a variable or y is standing in place of an unknown value because we don't know what number goes here. So what will y equal? Remember that 1.2. Good job. And so y is 1.2, and so 1.2 cups of what?
Cranberry.
Good job. So I want you to see if you can do the other one all by yourself. Remember, right now we know there are 0.8 or 8/10 of our pineapple. There are 1.2 cups of cranberry. So now all we got to do is see how many cups of lemon juice there are going to be. So what do we need to do? Somebody tell me what to do.
You multiply 5 times 4/10.
Correct. All right. And what is 5 times 4/10?
2.
Correct. So that's going to be 2 what?
2.0 or 2
2 cups of what though?
cups of lemon juice.
Good job. So does that answer our question?
Yes.
Yeah, it does. That's telling us that we're going to use 2 cups of lemon juice. We're going to use 1.2 cups of cranberry juice, and we're going to use 0.8 parts of what?
Pineapple juice.
Pineapple juice. So does that make 4 cups in all? If we add those 3 numbers together, does that make 4?
Yes.
Yeah, it does. Good deal. All right, so that concludes block 9. So I'm going to ask us a higher order thinking stem, and then we're going to actually look over our problem that I gave you for our vegetable soup exit ticket, which was our constructed response on this ratio assignment. So, how did the ratio of concentrate to water affect the taste of the recipe?
It made it stronger.
Mm-hmm. So, in other words, the more concentrate we have, the what?
The stronger the juice is.
Good deal. So, one more. Suppose we did not have a measuring cup. Maybe we only had a glass. You're not sure how much it'll hold. Could you still make the recipe taste the same?
You could.
All right, tell me what we could do. How could
Make
we?
a ratio.
Yeah,
Recipes are all about ratios.
yeah, we could do it with a ratio. Could we use like a measuring cup that had like ounces on it? Could we do something like that? Or like milliliters and do like 8 milliliters of the pineapple and then 1.2 milliliters of the cranberry and then 2 of the other one?
Yes.
All right. Or could we do like 2 milliliters of pineapple, 3 milliliters of cranberry, and 5 milliliters of lemon juice? Would that give us the same thing?
Yes.
Yeah, it would. So it would taste the same. So we could do it, but we got to have some way to do what?
system or like?
I agree. You got to have some way to measure it, because if you don't measure it, is it going to taste exactly the same?
No.
No. You might get it close, but it won't be exact. Okay. All right. So I'm going to exit out of this, and we're going to look at our vegetable soup exit ticket that we were all supposed to complete.
Friday.
All right. So this was supposed to be completed Friday by 2:15 p.m. Okay. Some people did it, but a lot of people didn't. All right. So what I'm going to do is we're going to kind of review over this, and then we're going to be given the chance to correct our work in our Google Classroom. Okay. So looking at this, part A, read that for us, Angel.
The vegetable soup recipe serves 5 people. You need to serve 15 people. Write a new scaled recipe listing each ingredient to serve exactly 15 people.
All right. So what do we do to create that new recipe, the scaled recipe? What do we have to do?
Multiply all the ingredients.
By how much?
3.
That's right. We're going to multiply them all by 3. So what is 5 times 3? We're going to keep going through this, and we're going to multiply each one of these by 3. All right. So what is 1/3 times 3?
Cup. 1 cup.
It is 1. Good. Because it's 3 over 3, which reduces to 1. All right. What about 4 times 3?
12.
Good. What's 1.5 times 3?
4.5.
Good. What's 3 times 3?
9.
What's 2 times 3?
6.
What's 5 times 3? Good. All right. So that was part A. Anybody have a question about how to solve part A? All right, let's look at part B. So part B says your friend is making the same vegetable soup recipe, but she has increased it even more to serve more people. She's using 10.5 large onions. So how many people does she plan to feed? Well, remember that 1.5 feeds 5 people. Okay? If this feeds 5 people, then that means 10.5 is a lot more than 1.5, right? So I want you to think about how you can solve that and why. All right, so we're going to continue. So once again, she is using 10.5 large onions. And so we're trying to figure out how many people does she plan to feed. Well, in order for us to figure out how many people she's going to feed, what we're going to do is we're going to take 1.5 and we're going to split it into however many sections we need to until we get to 10.5. So if we do 10.5 divided by 1.5, we will get 7. And so when we get 7, what we can do is we can take 7 and multiply it by the number of people that the original recipe serves. So the original recipe serves 5 people. So we need to take 7 and multiply it by 5. And when we do this, we learn how many people she plans to feed, which in this case is 35. All right, part C, it says you are serving fewer people, so you reduce the recipe. You determine you only need 4/5 of a green pepper for your soup. So how much olive oil will you need? So what we want to do is we want to take a look at this, and we want to take the new amount and divide it by the old amount. So the new amount was 4/5 of the green pepper. So we want to divide it by the original amount of green peppers, which in this case is 2 green peppers. But we know that we can't divide by 2 here, okay? So we know there's an understood 1. So what we need to do is actually multiply by the reciprocal of 2/1. And the reciprocal means that we're going to take 2/1 and we're going to flip it over. So when we flip it over, we are going to get 1/2. And we're going to multiply that by 4/5. So we know that 4 times 1 is 4. And 5 times 2 is 10. So 4/10 is actually our scale factor. So we're going to take 4/10 and we need to multiply that by the amount of olive oil. So when we do 4/10 times 1/3, so 4 times 1 is 4 and 10 times 3 is 30. But this isn't simplified. So we need to simplify this. So in order to simplify this, what we want to do is we want to divide both of these by 2. So we're going to do 4 divided by 2 and 30 divided by 2. And so when we get this, we will get our completed answer. And so our completed answer here would be 2/15. And this is our simplified answer. So we would need 2/15 cups of olive oil. All right, last but not least, Part D. Part D states, you have already made the soup for 5 people, and you find out that 3 more people also will have the soup. So list how much more of each ingredient needs to be added to the soup. So in doing so, what we can do is we first can figure out our scale factor. And so in order to do this, what we need to do is we need to think about how much 5 people actually is here. So in other words, when I say what 5 people and what it actually means is that 5 people are here already and they're already going to eat, but 3 more people join. So 3 plus 5 is what? It's 8. So since we get 8, that means that we need to determine what our scale factor is so that we can figure out how much of each ingredient needs to be added to this soup. So what we can do is we can do 8 divided by 5. And when we do this, we're going to get 1.6. So we need to understand that 5/5 is equal to 1 whole. All right. And so that means that our remaining amount would be 3/5. And so that means that 3/5 is equal to 6/10. So we need to take everything in here and multiply by 3/5 or 6/10 because 3/5 makes up the remainder of the amount of people that are going to be staying. So for instance, we would do 5 times 3/5. And we know that 5 times 3 is 15, and 15 divided by 5 equals 3. And we'll try another one. We'll do 1/3 times 3/5. Let's get a different color. 1 times 3 is 3. And 3 times 5 is 15. If we simplify this and we divide them both by 3, we would get 1/5. All right. I want you to complete the rest of these. That's this one, this one, this one, this one, and this one. All right. And we'll check your work. I hope this was a great example for each and every one of these problems. If you have any questions, you're more than able to comment me in the private comment. And I will see you on the next time.